All right. Okay. Well, happy Monday, everybody. It is week 7, so basically we got like 1 month of school left, and so I don't know how we feel about that. Um, I am I'm doing a lot of I'm traveling this week. I am traveling to Pittsburgh to attend the Python conference, and so let me just tell you about PyCon US. So apparently there's Python conferences around the world, and this one's for the United States, and it's in Pittsburgh, and so I'm going to be gone for a week, and I will return on Monday. So I'm leaving Wednesday, and I come back Monday. So I'm going to basically record lectures for Wednesday, Friday, and Monday. I'm sorry, that's like 3 lectures here. I'm gonna also have to adjust my office hours schedule. Um, I'll cover stuff. Uh, I will. Yeah, we'll try to keep you up to date with everything. Um, okay, and then also next week we have our one exam. Okay, so I don't want to call it a midterm because it's just the one exam, and it will. Oh, I need to publish this module. Sorry. Okay. Um, it will mostly be exploratory data analysis. Okay, I have so this is a great risk. Anytime somebody posts a sample exam or a practice exam, um, students might complain that the actual exam was nothing like the practice exam, and and there's going to be, like the actual exam, of course, is going to be very different from the practice exam. But as far as what it will be expected of you, it will be so you will see in this practice exam, I have like, here's some data, and then I ask you to do some, create some plots based on it, calculate some summary statistics, and do some work that way. Okay, so it's going to mostly be using a dplyr in terms of mutating new columns, grouping, summarizing. Okay, you might have to do a pivot operation, pivot longer, pivot wider, and then certainly some ggplot of producing visualizations. Okay, so I think I've given you a lot of kind of practice with that in both the assigned homework and the data camp homework, and a lot of kind of examples in class. And then you also have this practice exam, which of course is going to be different from the actual one. The exam is going to be done at home, and you are allowed to, search help and stuff like that. I can't limit that, but yeah, I'm gonna try to do my best to write an exam where you can't just copy and paste the questions into an AI and get the answers. But of course, that's I don't know. It's harder and harder to do something. So I don't. Yeah. But anyway, but you will have. But you will be doing the exam at home. Yes. Question.
Just to make sure, so the exam format will be like, there will be a data set given to us,
Yes.
and then there will be like, for example, 8 questions. And for each question will be, you have a final code or a final graph that you want us to produce, and then we have to write the code in order to produce the same graph.
Yeah. So the format of the exam is gonna look a lot kind of like our homework assignments, in that I will post like an RMD file. I'll post some CSV files, okay, with data, and then you will answer the questions in that. Yes, on the exam you have to write some code so that it produces either a table of output that I'm looking for, or a graphic that I'm looking for, or something like that. Okay, and then the biggest difference with the homework and the exam is that it will be in a constrained time environment, in that like I will, I'll publish the thing, and then your exam will be due like 2 hours after that. And so there is that time pressure, and it's not that like the time pressure, but it's just like I want to kind of make sure you're at least familiar enough with the concepts that we've covered in class that you can conduct it. And so, yeah, the greatest challenge for me writing the exam is correctly gauging and estimating everybody's kind of skill level. And I recognize there's a spectrum of skill levels, but trying to kind of hit that middle mark where the majority of students can finish within the allotted time. So that will be the exam, and that's scheduled for next Wednesday. So okay, and then but yeah, this week, things that will not be covered, okay, that will not be on the exam, will be the statistical tests that I've done. So I will not put on things like the t-test or ANOVA, and today I'll do a proportion test and things like that. So a lot of kind of mostly data exploration and visualization. And in my opinion, it's straightforward, but of course, that's of course I'm biased, and perhaps I'm when your professor thinks something is straightforward, it might be totally off the mark. So that's what we got there. Okay, all right. Today I wanted to kind of cover another statistical test, and this is a statistical test that allows us to compare proportions. So earlier we introduced the statistical test, the t-test, which allows us to compare the means of two groups. And we could say, hey, and the example we used was, here is some data where we have Las Vegas hotel reviews, and we wanted to compare, hey, is the average rating, the mean rating of a 5-star hotel different from the average, the score, the customer score, is the average customer score for a 5-star hotel different from the average customer score of a 4-star hotel? And when you did the exploration, it looked like there was a difference. It was like 4.3 versus 4.0 or something as far as the score that the customers gave. But we wanted to know, could that have just been a random fluke? And so we did the statistical test, and the test came back with a small p-value indicating that it is very unlikely to be a random fluke, because the probability of something like that happening by random chance is low. So that would give us evidence that the means are different. And we're going to do something similar, but this time we are dealing with categorical variables. Okay, and with categorical variables, you don't have a mean, okay, because you don't have numbers to average, but you will be dealing with a proportion, because with categories you can say what proportion of the M&Ms are red, or what proportion of people have black hair, or what proportion of cars are electric, right? So these are categorical variables. The car is electric, diesel, or gasoline, and you can't calculate the average, but you can calculate the proportion, and you can say 15% of vehicles are electric, or whatever it might be, okay? I'm making up numbers. And so I have a data set here. This is the animal service intake and outcome data set. This comes from, I think, I want to say Louisville, Kentucky. Animal shelter. So every every city in the U.S., there's animal control, and so if there's stray animals or lost animals, there's the dog catcher and or the I guess animal control, and they catch the animal and they bring them into the shelter and hopefully reunite them with their families or find families to adopt them. But in some cases, there's a sad end to the thing. And so this is data gathered from so Louisville, Kentucky. They published their data on data.gov. So again, some things, interesting things, and yeah, and depend. Sometimes the animals that they find, have are injured or diseased or they have to be euthanized. But anyway, this is the data that we have. What is this? I'm gonna click Don't Convert, and so I think I got this data set a few years ago, but there's there's a lot of records in here, 47,000 records, and they have information, and I think it's from multiple locations in the Louisville metro area. Whoops. And so they have different locations. The animals have they're ID'd, what jurisdiction, which I think is their zip code pretty much. And then the intake type, there are stray animals and fosters and owner surrender, disposal, I think. Yeah, so there, and then there's also lost. So there's different kinds of intakes, and then the they have different outputs, and then you have information about, was it a cat or a dog, and if it's and then if it's a dog or whatever. So animal type, you have dogs, cats. There's other animals, but like most of them, so livestock, most are by far cats and dogs, and then you have different breeds on, Chihuahuas and I don't know what these are. German Shepherd, Siberian Husky, a Pug, a Labrador Retriever, Pit Bull, different kinds of breeds. So anyway, this is the data set. Okay, so here I just thought, well, okay, let's just do some exploratory analysis, and we'll look at what are the different intake types. Okay, and we could, there's a few ways you could do this. So I import, I load up library tidyverse, and I load up our data, and I'm gonna just ask for information about it, and we have a bunch of variables, and as far as intake type, I can just do a table of it. So I can do animal. We will do animal. I'm going to select in type, and then I'm going to pipe this into table. Okay, and table will do this. And so we have different kinds of things. So I think the definitions of each of these is, like, this one is someone found the dog and brought it to the shelter, and I think stray is the animal control department brought in a stray animal off the street. Okay, and then there's also lost animals and things like that. Okay, so anyway, we'll just create a bar plot of this, and so we can see by far there are more kind of stray intake types, and next would be lost, and then we have different other intake types. Disposal, that's so sad. I think that happens when like the animal is like left at the vet for too long or something, and I don't know. It's just, or I think, well, I don't know. Maybe I think there's. Oh, this is hard to read. But this I think has all of the different animal reasons, and you know, some of the anytime you do data analysis, sometimes you are like, oh, some people are terrible, and it's because you read all these reasons for why the animal ended up in the shelter. But okay, I want to talk a little bit about some of the lines of code that I've written here. So one thing that you might want to do, and this is I think a very useful thing, is especially if you're creating a bar chart, if you want to rotate the text so it appears vertically, so it's easier to read, then what you will do is you will add this line for theme, axis text equals, and then for the text element you'll say angle is 90, vertical justification is going to be 0.5. That's going to center it as far as the text goes vertically. So now that it's rotated sideways, vertically is now the horizontal centering, okay? And then H justification means all the way to the right. And so you can kind of see, like, if I put in 0 here, it will be left justified as, you know, with respect to the text, which I think we want H justified, right justified. You know, if you do 0.5, then it will be centered with respect to the text. And so this is, you know, if you turn your head sideways, it's centered. Okay. And then similarly, vertical justify is like, where is it centered? And so you can put in 0 and it will appear, you know, as far as the tick mark and the line, then the text appears, the tick mark appears at the bottom edge of the text. And then if you put 1, then the tick mark appears at the top edge of the text. And in our case, we want it centered, okay, at the text. And that's that. If I turn off angle, then it's horizontal, which probably not useful. But you know, if you feel like having, you know, some kind of angle, you can have it like this. This is a 60 degree angle, which I don't know why there's such a huge thing, but the 90 degree angle is probably best. But I suppose you can rotate at 270 and you have this, and then you would want H justify 0, and it looks like that. If you decide you want your text rotated that way, I don't know. Anyway, this is I imagine this will be a useful thing for a lot of you. So anyway, that's done with theme here. Okay. What I'm going to do is I'm going to color in these bars using animal type. Okay, so we're going to change the fill color based on animal type, and so we can see the most common animals are cat and dog. And then apparently we also have rabbits and birds, livestock, guinea pigs. I don't know how many guinea pigs we have. How many? It seems quite, I don't know how you're going to find a stray guinea pig, but I don't know. I guess it's possible. But yeah, stray rabbit, you know, I remember I had a rabbit, and then he got out of its hutch, and then I don't know, never to be seen again. But yeah, that was a little sad for 5-year-old Miles. I'm a dog guy. One day I'll show you my dog. Maybe. Okay. All right. So anyway, I'm going to focus just on, we're going to look at stray animals and lost animals, and we'll look at cats and dogs, okay? So I'm going to just filter to stray animals and lost animals. So I'm going to filter animal type to be either a cat or a dog, and then remember, don't use equals. Always use percent in percent if you want it to be like one of a certain type. Okay, and then here we're going to do also lost and stray, and then and basically same plot, but I'm going to just filter to those two types and those two animals. So it's just basically it's just this bar and this bar is now what we have here. Okay, and we want to kind of what I want to know is there a proportional difference? And you know, when you have such a disparity in the count, so as far as stray animals, there's what, over 25,000, and as far as lost animals, it looks what is this, 5, so 7.5, 8,000, something around there. Eyeballing these numbers. So if you want to compare proportions, what you have to do is, rather than plot the count, okay, with geobar, we're going to change the geobar position to fill. Okay, so this code and this code chunk is almost exactly the same. The only difference is I'm adding position equals fill. A lot of kind of my reasoning and thinking is written in the comments of the R script, so please follow along with those. And so this is what we have here. Okay, so looking at this, here I'm going to forget about the view quiz. If we look at this, it looks to be that over half of lost animals are dogs, and just under half of stray animals are dogs. So it seems there's a difference between these proportions. Okay, and so you know, if I had to guess, so what is this? This is 50%. This is 75%. There's a faint line right here, so that would be what, 62.5%. So it looks to be about 60%. Approximately 60% of lost animals are dogs, and then I would guess like 49 or 49% of stray animals are dogs, if I am to just guess using the plots. And so, you know, our question now is, all right. Okay. The question now is, could this difference be just a random fluke, or does it actually reflect a true difference in our proportions, right? So it's similar to when we compare the means of two groups. We want to know, hey, is the mean of this group and this group, could that just be by random chance, that just by coincidence you happen to score, you know, higher, just randomly sample higher numbers over here and lower numbers over here, or does it reflect a difference in the population? Is it possible that in our intake data, just by random chance, we happened to get a few more lost dogs and fewer stray dogs? Or does this actually reflect some kind of phenomenon in the population where there are more lost dogs proportionally and fewer stray dogs proportionally? So the test there is we're going to do a proportion test. Okay, so so in order to do our test, we're going to have to get counts here. Okay, so here I'm going to take our animals. Okay, our animal table. I'm going to filter to just cats and dogs, and lost and stray. I'm going to group by the intake type, lost or stray, and group by the animal type, and then I'm going to just call count. And so this this will give us a count. Okay, I could also do a summarize and just do like an n equals n. Okay, that would work as well. So this so count will give us this. I can also do summarize. n is equal to n here, and that gives me the same values here. And so we see, okay, there are 3,098 lost cats, 4,547 lost dogs, 13,524 stray cats, 12,473 stray dogs. Okay. Another option is you can create what's called a two-way table. Okay, and we use this function called table. So table is going to create what we call a contingency table, and it shows the counts of observations for each kind of combination of our variables. And so when you use table with, say, the pipe selector, you have to select only the columns, okay? Only the relevant columns. Otherwise, it's going to try to form a table for all of the columns that are being fed into the function. So you really have to just select only the relevant columns, and in our case, it's going to just select those rows and columns, and then we'll call table. And so if I call table, it will do this, and we get the exact same numbers: 3,098, 4,547, 13,524, and 12,473. But this is arranged in a what we call a two-way form. Okay, right? So we have lost and vertical, cats and dogs, and lost and stray. Okay, same information. And then if you want kind of like row totals and column totals, you can take that table and you can pipe it into the function add margins, and this will give you row totals and column totals. Okay, and so we get the sum of lost animals, 7,645 lost animals in total, almost 26,000 stray animals in total, 25,997, and then in total we have 16,622 cats and 17,020 dogs. Okay, so when we look at this proportional plot, okay, it looks like over half the lost animals are dogs and less than half the stray animals are dogs. And so we want to know, we're going to perform a formal proportion test to compare the proportions of lost animals that are dogs and the proportion of stray animals that are dogs, to see if that difference in proportions, this approximately 60% versus 49%, is that statistically significant. So we're going to conduct the proportion test. So in our case, we're going to have the two sample proportion test, and the function we use is prop.test. And so the proportion test compares the proportions of successes in two independent groups. Now the label success is arbitrary. It's not, we associate success with actually a good thing versus a bad thing. And here it's just going to be, we're going to label success a quote dog, okay? That's not necessary, there's no no shade to cats or anything like that, but we just need to pick one of these categories to be the success. So we're going to say, so we're basically going to compare the proportion of dogs in lost versus the proportion of dogs in stray. Okay, so in order to do this, we need to provide a vector of successes, okay, with the counts of successes. That's going to be our x. So first we need the count of dogs that are lost, and then the count of dogs that are stray. So the count of successes for our two groups, and then we also need to provide an n, which is the total count for the two groups. So our two groups are lost versus stray. So we need the total count of animals that are lost and the total count of animals that are stray. Okay. So as far as our numbers go, the total number of animals that are stray is 7,645, and the total number of animals that are lost is 7,645. Animals that are stray is 25,987. And then as far as the quote successes, which will be our dogs, 4,547 for lost, 12,473. Okay, for stray. So these will be the two vectors, 4,547 and 12,473 for our quote successes, the number of dogs, and then the number of strays is this. So you have to provide these two vectors, and you do proportion test x equals this, and n equals this. Does that kind of make sense as far as the numbers that I have to put into this test for proportion test? And again, this is just to see, is the difference in proportions significant, okay? And so here it says this is the two sample test for equality of proportions with a continuity correction. And it gives us, so at the bottom we have sample estimates, okay? So the sample estimate, so based on, so if I do 4547 divided by 7645, 4547 divided by 7645, I get this number, 0.5947. So yeah, again, just eyeballing this is right around 60%, 59.5%. And then just eyeballing this over here, that's around 48%, okay? 48% dog, 59%, 59.5% dog. And our resulting p-value says less than 2.2 times 10 to the minus 16, okay? So, sorry, I've got this wall of text here, but this is the interpretation of the output of this proportion test, okay? So the null hypothesis is going to state that the true proportion of dogs for these two groups among lost animals and the true proportion of dogs among stray animals, okay, is that these two proportions are the same, okay? That the difference between the proportions is 0, that there's no real difference in the proportions that are stray, proportion of dogs that are lost and the proportion of dogs that are, proportion of lost animals that are dogs and the proportion of stray animals that are dogs, okay? And then the alternative is that there actually is a difference, okay? Is that these proportions are not equal, all right? And our output makes a p-value, and in our case, our p-value is really tiny, right? It's pretty much 0, 10 to the minus 16, okay? So 0.00015 zeros and then something, okay? If we use a significance level of 5%, our p-value is far less than that. And anytime your p-value is less than your significance level, that means you reject the null hypothesis. So our conclusion here is that the proportion of dogs among lost animals and stray animals are statistically different, okay? That this proportion of 59% versus 48% is not due to just coincidence, but that proportion is significantly different, right? So in our data, nearly 60% of lost animals are dogs, and this proportion is significantly different from 48%, which is the proportion of stray animals that are dogs, okay? In general, if you have a large data set and you do a proportion test, it's almost certainly going to be significant. So anytime you have, I would say, in general, like over 2,000, okay, if your counts are over 2,000 for your the X values, like the number of successes, if your number of successes is over 2,000, almost always, certainly, your proportions are going to be different, even if it's like a 1 percentage point difference, okay? Just that's often what happens. I don't want to say always, but it's frequently the case. But if you have a much smaller subset of data, then the differences may not be significant. So here I'm going to subset my data to just the first couple weeks in June of 2022. So if you look at the input date, all right, the input date comes in like this. August 1st, 2019, 12 a.m., okay? And so let me just kind of show you. So if I do animal and I'm going to select date, okay? And then we'll just look at the first, oops. I'm sorry, it's in date, sorry. Okay, so if you look at this, it says this is a character, okay? The data type is CHR, so it's in this kind of character thing. So what we have to do is we're going to use LubraDate to convert this into like a date time thing. Okay, so if you have data where you have like date information and you need to convert from character information into date information, one of the functions you can use is called parse date and time. So let me just show you how this is going to work. So again, I'm going to just I'm going to use mutate to create a new column. So if I do select indate, and if I say mutate, and we're going to say date is equal to parse date time. Okay, so there's parse date, and that's if you only have date information. But here, because it's date and time information, even though it's all zeros, okay, we have to say we're going to parse date and time. And the format of this is that the information comes in with year, then month, then day, then hours, minutes, and seconds. Okay, I didn't like that. What did I do? Oh, okay, I have to say we're going to do it for the. Okay, so now let me select indate and date. Okay, so now we can kind of see. So this gets, so it looks almost exactly the same afterwards, after conversion, but this is just character. All right, so it's just like typewriter text. So, you know, we could have gibberish in here, whereas this over here, this says DTTM, so this recognizes it as a date time object. Okay, so like if I just select the indate column and I pull it, okay, this is just, you can see everything's in quotes here, and over here after I convert it and I select the date column, this also looks like it's just in quotes, but there is just a little bit of information. It has like UTC indicating there's like a time zone and things like that. So this has been correctly converted to date time. Okay, and then once you have it converted to date time information, then you can pull information like what is the year. Okay, so for example, I can mutate another column where I just want to get the year out of the date time. So I'm going to call, I say, give me year on the date, right? And it extracts out, it extracts out the year, okay? Whereas if I didn't parse this thing and I just say, hey, try to extract the year from, oops, from the intake date, okay, it doesn't know how to do that. Oh, look at that, it's smart enough and it figured it out. Okay, all right, well, it figured it out, but generally you should parse the date and then it will extract that out. So you can pull out the year from the date, you can pull out the month, okay, and it extracts out the month, and you can pull out the day. Sorry. Okay. All right. I'm now curious. How good is this? All right. If I did this with just the indate, is it smart enough to do this? Maybe. Oh, it's thinking. Oh, but it did. That's really good. Okay. Lubridate is amazing. All right. This used to be such a pain. I don't know how to tell you other than like back in my day we had to, you know, now we have tools. Okay. Well, yeah, you don't even have to do this parse date time. You can just go straight, and Lubridate is smart enough. Okay. Well, anyway, I guess so. All right. Well, anyway, so I've extracted out the year, and here we're gonna just say, okay, I want, now that I can extract out the year and the month and the day, I'm gonna say filter it just to the year 2022, and the month June, and the days between the 1st and the 15th. And so this will give me just those rows, okay? And we have a total of, I don't know, 404 rows or something. Okay, we're gonna group by intake, animal type, and then we'll make our table. And so this is our resulting table. And so here now we have a total of 78 lost animals and 326 stray animals. Of those, 36 of them are, of the lost animals, 36 are dogs, and of the stray animals, 125 are dogs. So my proportion test numbers are going to be 36 and 125. Those are the number of lost and stray dogs. And then my total N is going to be 78 and 326, which will be the total number of lost and stray animals in total. Okay, as far as comparing lost. And so here my proportion is 46% of lost animals are dogs, and 38% of stray animals are dogs. And now we want to know, is there a difference between these proportions? And now I get a p-value of 0.2556. Okay, indicating that if I used a p-value of say 5%, we would not reject the null hypothesis. And so for the data that we have here, where we only have a total of I guess 400 animals in our data set, and only 36 lost dogs and 125 stray dogs, this this does not tell us that the proportion of dogs among lost animals is significantly different from the proportion of dogs among stray animals in that time period. Okay, so when we looked at the full data set, yes, there is a difference, and that difference is significant. But when we look at just a small segment, okay, we are observing a difference still, but based on this data alone, it is possible to end up with these kinds of differences from just random coincidence. Okay, by random coincidence, we happen to get a few more dogs among the lost animals, and fewer dogs among the stray animals. It's possible that just by random coincidence. Okay, so the proportion test, so these two sample proportions are not statistically significantly different. Okay, are not significantly different at the 5% significance level. And basically your results really depend on your sample size. Again, rule of thumb, if it's over 2,000, almost certainly going to be significant. When you have smaller proportions, that's when it really counts in terms of like, are these proportions actually different or not? So this is what we have here. Okay, I have completely forgotten about view quiz answers. Today is week 7 Monday. I guess I'll just give you all 3 answers here. Well, I hope people watching the video still watched the video and didn't just fast forward to the end of the video. But all right, okay. Our 3 answers are C, then B, then E. So I guess I'll type this out so we can all see it. C as in cat is your first answer. B as in bear is your second answer, and E as in elephant is our third answer. And I know, every time I'm like, I have to remember to fix that mistake about the wrong view quiz answer. And I always say this, and then as soon as I get to my office, I completely forget. So I will try to remember. But maybe somebody send me an email and just say, friendly reminder, fix that view quiz answer on that one day of the week or something. But anyway, okay. So these are your 3 view quiz answers for today, and that's it. Okay. So this is if you go as you're investigating your data and stuff, if you're dealing with categorical data, you might be interested in calculating proportions and just saying like, hey, it looks like the proportions of this is different for this group and that group. And maybe that difference in proportions is statistically significant and maybe not. And this is how you would go about testing it. Okay. All right. So we'll wrap things up here. have a great rest of your day. And again, I will be traveling for the rest of the week. So I'll just record videos and post them. And you don't have to come to the classroom. Or you can come to the classroom and watch them peacefully, I guess, in a less distracting environment. Okay, all right, have a great day.